This is the top slot prototype PCB. I've got quite a few things plugged into it. I've got some LEDs here on the Pico output port. That's running off the GPIOs from the Pico. This one's running off the hardware latch, and this is an input port, and the OLED just displays a startup banner. That doesn't do anything at the moment. And I've got a couple of flying leads here. They're connected to 3.3 volts, and that means I can put ones on some of the inputs here. So I'll start the code up, and that's loaded in some Pico and latch commands in the main menu there. So I can send all ones to the Pico output port, and the orange lights come on. And I can send AA, so that's an alternating pattern, to the hardware latch over here. It's a bit harder to see, but they have all come on there. They're pretty dim. I didn't want to put too much load on the hardware outputs there. And they are independent, so I can now send AA to the hardware latch and to the Pico latch, and send all ones to the hardware latch. So they're independent. They use different states in the interface. There's a few spare states, 4 I think, and I'm using 3 of those, one here, and one over there for the inputs. So if I run this program, latch in, so that will now read and display in hex the value that is coming in on this input latch. So if I stick a pin in here, and a 1 has appeared, that's now 4. And if I stick another pin in here, there you go, 8, 4, and I can move these around, and that's an input latch there, A0. So that's correct. And the code for, I'll pull those out because they're actually on 3.3 volts and I don't want those flapping around. And the code that runs this is coming out of the Pico as before, so it's all a self-contained sort of hardware board, and whatever program you put in here supports whatever hardware you've got attached. Turn that off. Actually, if you turn off the organizer, the hardware stays there because the hardware states stay there because it's powered by USB. If you look on the back, I've got some bodge wires there. The capacitor is because I've got a ground problem on this board, and that's just filtering the input to the hardware output latch. And there was a wire left out. It wasn't connected on the schematic in KiCad. And what's the other wire? The other wire's there's a better ground connection for the bad ground problem I've got. So that is now working quite well. It's 8 bits of output here, 8 bits here. This can be configured as an input port, but I haven't done that. This is an input port, but that's a hardware latch there, which goes on to the bus. This bus down here. This is bidirectional because it's GPIOs, but you'd need some way of setting it up. There is another state that's free in the interface, but to do that you've got to be a bit careful if you've got hardware driving an input, that you don't send the wrong state and end up with outputs driving each other. That might cause problems. So it's a bit tricky having a bidirectional port. Actually, it's a bit more natural to have output ports and input ports because of the way the states are set up. The two of the 4 states that are available are input, and 2 are output because of the OE signal, the output enable signal. So it sort of splits better that way. And the reason the states are available is because this Pico, the interface for the top slot only supports ROMs. It doesn't support RAMs, and it doesn't support segmented devices with large address space. So you lose a lot of the functionality that you need to drive those, and you can use that for hardware instead. So if you wanted a lot of outputs, you could use this state here, the GPIO state as I'm using it at the moment, to be a device select, and you could have 255 or 256 8-bit output latches or 8-bit input latches, which will give you quite a lot of inputs or outputs. So you could use this state here as a multiplexer for the selection of the other latch. Or I suppose if you just want a few GPIOs, you could just have some sort of pattern, so you can have GPIO number sent first, or the top bit set gives you GPIO number, and then you use second bit set for the 4 bits and another bit set for another 4 bits, and you could then send stuff out of the Pico GPIOs and use more of those. Although a lot of them are actually used for the interface at the moment, so that wouldn't work too well. But it could power a latch or something. You wouldn't need hardware latches. You could actually use the Pico to do some decoding of devices, I2C or something like that. But that's now, I think, more or less fully functional. So we've got A's there. Let's put A's on the other latch. There you go. And then turn all those on. And yeah, what I'm going to attach to it, don't know, but you can attach almost anything to it.